So moving on to the next question, we are here to predict the viscosities of molecular oxygen, nitrogen and methane at 20 degrees Celsius and atmospheric pressure and express these results in megapascal seconds, and then we will compare the results with the experimental data. So now here for finding out the viscosity for low density gases, the viscosity of a pure monoatomic gas of a molecular weight m, it is given by the Leonard-Jones parameter as mu is equals to 5 by 16 under root pi m kt upon pi sigma. We are taking the formula of viscosity as 2.6693 into 10 to the power minus 5 under root of molecular mass into temperature sigma square and rho u. So this is basically used for monoatomic gases with the low viscosity. Here we are writing the formula 6693 into 10 to the power minus 5 . Now first we will calculate the viscosity for O2, that is oxygen. As we know, the molecular weight of oxygen is given as 32. For finding out the values of sigma square and rho u, we will take the help of appendix, and from here, as you know that O2, here the value of O2 sigma is given as 3.433. And for finding out the value of rho u, first we will find out the value of E by K. So corresponding to O2, E by K is given as 113. And here we will use and we will take the help of second table E2, that is collision integral, that is used in Leonard-Jones parameter. So for finding out rho u, we need to find out the value of Kt by E. So what we will do is, since E by K is given as 113, so K by E will be what? 1 upon 113. Then we will multiply both sides with temperature, that is K into T, and here temperature, what the temperature is given as 20 degrees Celsius. So we will convert it into Kelvin, that is 20 plus 273. Now we will find out the value of Kt by E, which will be equals to 20 plus 273 divided by 113. That we are getting the value of Kt by E as 2.59. Now corresponding to this, the value here, you know that 2.6 is nearly equal to 2.59. So the corresponding to this, rho u is given as 1.08, but it is little less, so we will take some value as less and we will take the value as 1.086. This is purely based on approximation. Now putting all the values in this equation, we will find out the viscosity as 2.6693 into 10 to the power minus 5 into molecular weight is 32 into 20 plus 273 divided by 3.433 whole square into 1.086. Putting these values in the calculator, we are getting the value as 2.02 into 10 to the power minus 2 millipascal second. So this is the value of viscosity for oxygen. Now we will find out the value of nitrogen. So as you know, the molecular weight of nitrogen is 28. Now we will find out the corresponding value of sigma of nitrogen. It is given as 3.667. Sigma is equals to 3.667, and its corresponding rho u again the same method, the same steps need to be followed. That is, first we will find out the value of E by K, which is given as E by K is given as 99.8. Again K by E is equals to 1 upon 99.8, and multiplying both sides with the temperature, that is equals to 20, and then converting it into Kelvin, 273 we will be adding to 20 degrees Celsius. Now calculating this as 293 divided by 99.8, we are getting the value of kT by E as 2.935. From this table, that is table E2, we will find out this value as 2.9 is 1.0482, and somewhat we need to increase the value of kT by E, but here this is reducing, so this value we will take little less from 1.0482. So by approximation we will find out the value of rho u as 1.0447. This is purely based on approximation. Now putting all the values here as 2.6693 into 10 to the power minus 5 into here the molecular weight is 28. Again converting temperature to degree Kelvin, and then sigma is 3.667 whole square, and rho u is given as 1.0447. Putting this for the easier calculation, what we can do is, there is a method to store the formula in calculator as well. So what we need to do is just put the value of ABC and then we will directly get the value. So these are the short tricks that you can apply in your exam as well, so as to decrease your time and increase your efficiency. So again we will calculate the value of viscosity for nitrogen. We are getting the value of viscosity as 1.72 into 10 to the power minus 2 MPa/s. So this is the value of nitrogen. Now coming to the third viscosity that we need to find is of methane, that is CH4. So first we will calculate the molecular mass of methane. As we know, the molecular mass of carbon is 12 and hydrogen is 1, so it will be like this, and the total molecular mass is 16. Now we will here find out the value of CH4, that is given in hydrocarbons. Corresponding to this, the value of sigma is equals to 3.780, and the value of E by K is equals to 154. Again repeating the same steps, K by E is equals to 1 upon 154, multiplying the temperature both the sides, that is 20 plus 273, so as to get into Kelvin. 293 divided by 154 is equals to 1.902. Here we are getting the value of kT by E. Again kT by E, here we are taking the value of 1.90 is given as 1.198. So it is little more than, that is 1.902. So we will take the approximation of sigma as 1.197. Now putting all these values in the equation, that is mu is equals to 2.6693 into 10 to the power minus 5 mt sigma square rho mu. I hope you have now, till the time you have learned the formula for these kind of gases. Into 10 to the power minus 5, molecular mass of is 16 for methane, temperature 20 plus 273, and sigma square is given as 3.780 whole square, and rho u is given as 1.197. Again, putting all these values in the calculator, we will be getting the value of viscosity as we are getting the value of viscosity as 1.07 into 10 to the power minus 2 MPa second. So all these are the values for the three gases that we have found out, that is oxygen, nitrogen and methane. So now, as in the question, it is also told to compare the experimental value. So when we come to the BSL, there are for which some we are given in the table 1.13. Okay, so CH4 at around 20 degrees Celsius, the value is given as 0.0109. So what we are getting as 1.07 into 10 to the power minus 2. So that is nearly equals to same. Now for N2 we are getting, okay, so we will just write also experimental data is 0.0109. So we are getting as 1.07 and they are getting as 1.09. Now for O2, that is at 20 degrees Celsius, they are getting as 0.0204 or 2.04 into 10 to the power minus 2 MPa second. This is experimental data. And for nitrogen, we are getting this value as 1.75 into 10 to the power minus 2 MPa second. That is for experimental data. So as you can see, when we compare all these three values, we are just getting an error of 0.01 or 0.2. So that is nearly the same. So from this, it has been proved that we can use this empirical relation or equation for these kind of gases at atmospheric pressure. Just to remember the thing that this is given as atmospheric pressure, and for corresponding temperature we can find out the value of sigma, we can find out the value of E by K. Corresponding to that, we will find out the value of KT by E, and then we will find out the value of sigma U for each of the gases. Just then we will put the value in the empirical relation of viscosity and we will find out the values of viscosity.
Okay, so now we'll see how to calculate viscosity of gas mixture. We have this question. This question is from PYQ 2018 and it is also an unsolved question from BSL, unsolved 1A.4. The following are available for viscosity of mixture of hydrogen and freon which is CCl2F2, that is difluoromethane at 25 degrees and 1 atm pressure. Mole fraction data and viscosity data is given. Viscosity of pure component. To calculate the viscosity at 3 intermediate composition by means of equation 1.4, 15 and 16. So first we'll write our equation. Viscosity of mixture is given as sigma alpha is equals to 1 to n alpha x, that is mole fraction alpha, viscosity alpha, sigma beta x beta, phi alpha beta. Phi alpha beta is given as 1 upon under root 8, 1 plus m of a upon m of b to the power minus 1 by 2 into 1 plus mu of a upon mu of beta to the power 1 by 2 into m of beta upon m of alpha to the power 1 by 4 whole to the power 2. So using this formula we'll calculate for given components. Our components are hydrogen and freon, that is CCl2F2. Their masses are, hydrogen has mass of 2.016 and CCl2F2 has a mass of 120.92 grams per mole. Their viscosities are, as we can see, when mole fraction of hydrogen is 0, that is 100% freon is present, viscosity is 124. And when hydrogen has mole fraction of 1, viscosity is given as 88.4. Now we will calculate alpha beta, because to calculate viscosity of mixture we will need alpha and beta. So we'll make a table. We'll calculate phi alpha beta. So for this we will make a table. Alpha and beta. We'll take alpha is equals to H2 and then beta is equals to CCl2F2. Then alpha is equals to H2 and beta is equals to H2. Then we'll take alpha is equals to CCl2F2 and beta is equals to H2, and we'll take CCl2F2 as alpha and beta also CCl2F2. To calculate phi alpha beta, we'll need m alpha m beta. We will also need mu alpha upon mu beta, and we will also need m beta upon m alpha, which will be the reciprocal of this one. Okay. Calculators are there. We will calculate this value. M alpha is 2.06 and M beta is 120.92. Mu alpha is 124 and mu beta is 88.4. This will be the reciprocal of this one. Now we will calculate phi alpha beta for H2 and CCl2F2. Phi alpha beta is coming out to be 3.934. For H2H2, this ratio will be 1, this ratio will also be 1, this ratio will also be 1. Eventually, phi alpha beta will also be 1. And similarly for this one also, everything will be 1. Okay, we will calculate for this. For this, m alpha m upon m beta will be this one, 59.98. And the value of m beta by m alpha will be this one. So phi alpha beta will come out to be 0.0 0.6920. To calculate mu of mixture, our formula is alpha is equals to 1 to n alpha x of alpha mu of alpha upon sigma is equals to beta x of beta phi alpha beta. We can expand it as our alpha is going from 1 to 2 and our beta is also going from 1 to 2. We can expand it as mu of mixture is equals to x of 1 mu of 1 sigma beta goes from 1 to 2 x of beta phi of 1 beta plus x of 2 mu of 2 1 sigma beta x of beta phi of 2 comma beta, which can also be expanded as we will expand this as from beta going from 1 to 2, that is x1 when beta equals 1 phi 1 1 plus x2 when beta is equals to 2 phi 1 2. Okay, similarly we'll expand this x1 phi 2 1 plus x2 phi 2 2. We will consider this as sigma 1 and we will consider this as sigma 2. Our sigma 1 will be equals to x1 phi 1 1 plus x2 phi 1 2 and our sigma 2 will be x1 phi 2 1 plus x2 phi 2 2. We have given 4 mole fractions, that is x1 is given as 0, then 0.25, then 0.5, then 0.75 and 1. Eventually x2 will be 1 minus x1, that is 1, 0.75, 0.5, 0.25 and 0. For individual x1 and x2 we will calculate sigma 1 and we will calculate sigma 2. So for this this term will be 0 and x2 will be 1 and 1 into phi 1 2. Our phi 1 2 is 3.934 and phi 2 1 is 0.6920 and phi 1 1 is equals to phi 2 1 is equals to 2 is equals to 1. So this comes out to be 1 into phi 1 2, that is 3.934. Sigma 2 will be, this will be 0 and this will be phi 2 2, that is this will be 1. We will calculate this for all our molar fractions. एक minute pause कर. So we will calculate this and this is coming out to be 3.200 and this is coming out to be 0.773. Similarly, we will calculate all this. This is coming out to be 2.467 and this is coming out to be 0.546. This is coming out to be 1.734 and this is coming out as 0.319. This is coming out as 1 and this is 0.0092. Okay, now we will calculate this term whole. We will call it as A and we will call it as B, so that are A and B. Okay, so we will calculate A. A will be 0 as x1 is 0 and B will be 88.4. For x1 equals 0.25, A is coming out to be 6.9 and B is coming out to be 120.3. For 0.5, A is coming out to be 18.1 and B is coming out to be 113.6. For 0.75, A is coming out to be 38.2 and B is coming out to be 97.6. And for x1 equals 1, A is coming out to be 88.4 and B is 0. Viscosity of mixture will be equal to A plus B, that is 88.4. This will be 6.9 plus 120.3, that is 127.2. 18.1 plus 113.6, this will be 131.7. For mole fraction equals 0.75, viscosity of mixture will be 38.2 plus 97.6, 135.8, and this will be 88.4. Okay.